Hi everybody. For the people that don't know me, I'm Alessandro. I've been the maintainer of a few open source projects during my career, and I currently work as a director of engineering at Volton Labs, where we maintain some open source projects, where the most famous one is probably Apache Arrow, and we are hiring if you are interested in working in the open source field. I'm also founder of a custom software development company in Italy and a member of an investment fund in Italy too. And I wrote two books, which are the Modern Python Standard Library Cookbook and more recently a crafting test-driven software with Python. The presentation that you can see here is mostly took from the content of the crafting test-driven documentation software that I recently published. Let's start talking about documentation. There are multiple ways that you can organize and think of your documentation. But most recently, one of the mostly widely used is probably to divide the documentation in parts that are learning oriented, so things like tutorials that try to teach you something, parts that are task-oriented, so a section of the documentation where you want to learn how to do a specific thing, usually the how-to guides, and parts that are oriented toward explaining you how the system works or how internally the things are and things like that. And the last part is the reference, which is oriented toward looking up the information that you need. The way those kinds of documentation can be grouped at high level is probably in having those that are text-oriented, so where the majority of the content is human-readable text, and those that are code-oriented, so where the majority of the content is code and in the language that we are using to communicate to the machine. Let's start talking about how we can test the text-oriented ones first, so the documentation for humans. And the majority of that kind of documentation is written by mixing plain natural language, so English or Italian or whatever, where you explain to the user what you are going to show, what you are trying to do, or what it can expect from the code, and then interleaving that explanation with the actual code. So there might be an example that shows how to actually do the thing that you are explaining. If you think about any project documentation, there is usually the first page is about how to do the usual hello world case, where you have the setup of the framework and the snippet that helps you copy and paste what you need to start the most simple example. That kind of documentation is fairly complex to maintain. Everyone who wrote a framework or a library probably knows, because it's easy to get the documentation out of sync with the real code. So for example, if you update your framework, how can you find all the places in the documentation when you mentioned the function or the class or the method that you changed, and make sure that they still make sense, so that they still do what you expected they were doing and you are still explaining the right thing to the end users. This is a very simple, minimal example of a documentation that I made for the purpose of the presentation, where I'm documenting how to use a library to make contact book applications. So here it's mostly explaining how you can add a new contact to your contact book and how you can list the contacts. And the question is, if I how my application works, what's going to continue guarantee that the ls commands still does list the contacts that I have recorded if, for example, I decided that it's more readable for the end user to use contact list instead of ls, given that the majority of my users are probably not going to be Unix system administrators. And that's exactly the part that we want to test. We want to test that the commands or the code that we are showing in the documentation still applies and works correctly with our currently released code, so that if we did any change to the application, the code actually works as expected. And that seems very simple because we just have to update the documentation with the changes that we did, and we know very well what we changed because we wrote the code, and we know the documentation very well because we have written it. But in reality, it's nearly impossible for any human to remember where all those code parts that are referring to the code that you changed are, and it's not something that you can usually solve with a simple grep or something like that. So we can test the natural language part. Obviously, that's very hard. Probably you will be able to do something about that, but that's the very hard part that we are not going to cover now. So taking for granted that the explanation reflects the code. So if my code works, it means that the explanation that I have associated to that code still is valid. All we have to do is to take the code that we have in our documentation, extract it from the documentation, run it, and make sure that it continuously works and continuously does what we expected it will do. Also, to do that, we probably want to compare the code to the expected result. For example, in the previous list, in the previous page that I have here, let me see if I have, yeah. In this case, I want to have still the code on how to do that, but I also adding a section with the result of that code. In this case, the output of name and the phone number of the person in my contact book. So here now I have both the code and the expected result of that code. And this is helpful because not only makes more easy to understand for the reader the example, because it has also the expected outcome of it, but it also allows us to start testing this, because now that we have to take this snippet, run it, and verify that the output is equal to this one. So we are now able to verify our code example because we now have also the expectation about the result. Not different from most unit tests or any kind of simple test that you can think of. Now, can we do that? Obviously, it's something that we can do manually or write a snippet that does that, but that's not a very convenient way. There are better tools that are explicitly designed to do what we are talking about. Extract all the code snippets from your documentation, run them, and compare them to the expected output. And the most widespread one is Sphinx docs test. If you ever wrote documentation in Python, there is a high chance that you ended up using Sphinx because it's probably the most widespread documentation framework for Python. And the Sphinx docs test is a plugin for Sphinx that implements support for doc test. For the people that don't know what doc test is, it's a Python module that it's actually embedded in the Python distribution itself, so it's part of the standard Python library. And it allows you to test the doc strings of methods, usually. The main purpose of the original doc test is to test the doc strings of your Python code, but more generally to test code that is inside any form of documentation. So it has a specific syntax for supporting wildcard values or formatting, because the output might not be formatted exactly as you expect, or things like that. In the previous example that I wrote, if I run in this case, this one, you can see that there are two sections: add listing contacts And here I added support for doc test. So I just have to run make doc test on that documentation project. And what happens is that it will find that there are one document, which is the Sphinx page that we were looking at. Inside that document, there were two tests, one for each section. The first test is the test that verifies the add up run contacts add name and phone number command. And the second test is the one that verifies the else command. And it tells me that both tests passed and none of them failed. This means that my documentation currently has code examples that are correct, that do what they are expected to do. For the first case, there is no expected output. You can see that there is no second cell. So it means that it just verified that running that code does not crash. That's all it could do without having an expectation. While for the second example, we have the expectation. So we have the second block where there is the output of my code block. And in that case, it could actually verify that running the first code block will result in the output contained in the second code block. The question might be, okay, great, we know that Sphinx doc test can do that for us, but how do we actually write the documentation in a way that it can work with Sphinx doc test? Obviously, you have to apply some minor tweaks. So you just have to use different directives. If you previously used Sphinx, you probably know that for injecting code blocks, you would use the code block directive. While if you want to use doc test, you have to use a different directive, which is the test code directive. And the test code directive is where you are expected to put your code to test. So the parts of the code that need to be executed and tested. So going back to the example, this will be our test code block, okay? While the second part, the second block that we have, the second directive in Sphinx, is test output. Test output is, again, an equivalent of the code block. So from the point of view of the user who faces the final result, it just gets rendered as a code block. But it tells doctest that that's the output of the previous code block. So going back to our example, here we have the test code block, and here we have the test output block. This way, doctest knows that this is the code to run, and this is the expected output that should be compared to the code that I executed, to the output of the code that I executed. Finally, we have a test setup block. The test setup block is again an equivalent to a code block, but that doesn't get rendered in the output. So it's code that gets executed but never shown to the end user. So for example, you can use it for fixtures, so to set up your database or whatever, depending on what you're documented. If you need to do anything so that the example can run, you can put it inside the test setup. For example, here we can see the actual code of the documentation page that I shown you before. First of all, we start with a test setup section. And in the test setup section, we are creating the contact application. So the app value is made available by the test setup command, so that then all the other examples can refer to the app without having to recreate it every time. So we can keep up the example minimal and avoid confusing the user too much. Then for the first example, for the first documentation section, we have the test code, because we just want to test that by invoking that command, it doesn't crash. And then we have the second example where we run ls, and we verify that the output is the expected one. This is actually a convenient structure, because if you follow everything all together, given that the context of the variables is the one for the documentation page. So all the test examples in the same page share the same variables. So we create a new empty application at the beginning, we add the contact there, and we verify that the contact was both visible by ls, but also added correctly, because here we are printing the value that we added there, okay? So that's also convenient in the way that you might not have to be forced to produce, to mix too many concepts in the example. Otherwise, what we would have to do is in the add example, also add a listing of the contacts just to verify that it was actually added. And at that point, the documentation will become confusing for the user because we were talking about adding, but in reality, a big chunk of our code will be using things that we have not yet even introduced, given that listing is a subsequent section. So this way we can avoid adding the listing to the first example and rely on the result of the first example in the second one to both verify that we are listing and that we correctly added what we expected. Then we have the other, if you remember the first definition of documentation that I explained, we have the other part, the documentation that is where the code is the majority and the human readable text is the minority. That's usually what you have in a reference, where you have code as the primary thing, and maybe you have a short explanation on every class, on every method, and things like that. In references, usually you have a condition where the amount of human readable text is flipped compared to the standard documentation. In this case, we can use another tool that is available in PyTest. Why I tell PyTest? Because here we are approaching the world from the opposite direction. So in the context of human readable documentation, we were approaching the testing from the documentation itself. We had to extract the code from the documentation. While in the case of references, we come from the other direction. So we have to extract the text, the examples from the code. So that's why one starts as a Sphinx command, because it has to parse the documentation and get the pieces. And the other starts as a PyTest code, because it has to parse the code and extract the pieces. And in practice, does the same exact thing that we were discussing previously, and allows us to make sure that the examples that we write in our code are actually working. So are actually something that the developer that has to use that function class or method after us can rely on, instead of being very upset with what we did. And here we have a very simple example. Here I just took this function, placed it in a Python file, and you can see that I have my function that just returns a constant text code. But in the docstring, I have a small piece of code, a snippet that invokes the function and returns 42. So what we are doing here is showing how to use the function, just invoke it, and showing what's the output of the function in that example. If I run PyTest doctest modules, what PyTest will do is pick the code there, extract the code from the doctest. So it will only pick that something. So the code for doctest, the code is identified by the piece of text that starts with the 3 arrows. Okay, so you will know that that's code. And then we run it, and we compare that code to the output. And the output is the part without the arrows. So that's what what PyTest will do. And will tell us, well, your module had one example, and that example, if I test it, works correctly. Obviously, in this case, the code is incredibly stupid because it just returns a context. But the example applies in many other cases. There is one last thing that I want to introduce to you very quickly, because not many people might know it. Probably many Python developers know and use iPython as an interactive shell, but iPython is actually a very powerful testing tool too. There is a iPython plugin for Sphinx, which embeds all the machinery of iPython inside the Sphinx and allows you to write doc tests using the iPython special features. For example, this is that I added to a documentation, okay? So I started with the iPython directive. The top block is a piece of restructured text, so of the documentation. And when I compile my documentation, what I will see as the end user is this part. The interesting feature of the iPython support for Sphinx for documentation is that when you compile the documentation, so when you render it, it will actually execute all that code. So it will start by doing x equal to x power 3, and the expected output is 8. And the output that you see here is actually not the one that you've wrote, but the one that results from executing what you've wrote. So you don't have to spend the time updating the output if it changes in a way that it's minor. For example, let's think that we made a function, the original function, we invoke our something function, which used to return 42. If tomorrow it starts to return 50, we wouldn't have to care, because iPython would just execute the function and place there the output of the execution and ignore the result. So if it's, in general, the problem with iPython is that it's very slow, because it gets executed, all the Python code gets executed while compiling the documentation. So compiling the documentation becomes very slow. And it doesn't have any major benefit compared to using dot test, which is faster and from some point of view easier to use. So why I'm talking about it here? Because it provides you all the power of iPython itself. So if in your code, in your documentation, you have to add an example where you are listing the context of the disk, or timing with time it a function, or whatever you can do in iPython, you will be able to actually run that code inside the documentation. So suppose that you have an example where you save 3 files. To show that the 3 files were saved, you could actually just do a list of the content of the directory. While previously with just doc tests, we couldn't, because we could only run Python and not shell scripts. So by using iPython, we have the advantage that in our documentation we can include all the features that iPython provides out of the box. Okay, that's mostly what I wanted to show you. If you want to know more, you can read the book and let me know if you have any feedback. And if there are any questions, I'm available for them.
All right, thank you, Alessandro. So we have 4 questions here. Oh, 5 questions. So the first question says, can we use test setup block to work with docstring doc test? Let me go again. Can we use test setup block to work with docstring doc test?
What's the end result that you are trying to achieve?
If the person is in the car.
Wait for the microphone because I can't hear you.
Let's say you want to test a function in the class So you have the self attribute you need to pass to the function, eventually instantiate your class instance. How do you do this? Because you showed the setup where you can import your stuff, but that's look like RST file. Is it something that you write directly into your docstring of the function, or you can have a more global approach, or you need to do this for each single function?
Well, in this example, everything is driven by the documentation page. So as I explained before, the content of the example of the doc strings is totally ignored. So the doc test that we have here extracts the code from the documentation, not from the methods that are in the documentation. So if you have a reference, if you have, for example, autodoc of a class, it would absolutely do nothing with it. If you want to verify and extract information from the docstring themselves, it's probably easier to use the doctest modules extension for PyTest. In that case, whatever you have written in the docstring will get tested, and you can extend that test in any way you want by using the standard syntax of PyTest. So you can add fixture, you can add whatever you might need to do to expand it. I hope this answers your question a bit.
All right, great. The next question, how do you deal with complex snippets? How do you deal with complex snippets that will need stuff like mock data?
Okay, that's a good question. And probably this way, in the sense that you would put the mock data in the test setup. At least that's what I would personally do. There are people who ship the mock data as a file inside the Sphinx project. That's something else you can do, and then you can load the data in the test setup. But I personally prefer to have everything in a single place so that I can look at it at once. And so I would probably hard code the mock data as a dictionary, list of dictionaries, or whatever you want. And if it's a data on a database, for example, I would probably have the create table and insert commands in the test setup so that they are not visible to the user, but are visible to any developer who needs to touch the documentation.
All right. The next question is actually two questions combined together. Should we put unit tests as documentations and run unit tests with doc tests? That's the first one. And the second one, what are the use cases to keep using separate unit tests?
The two approaches are complementary, so there isn't one where you have to start first in reality. The testing the documentation is testing the documentation itself, so the examples that you've wrote for your users and things like that. So it serves a specific purpose, and you need it to make sure that the tutorials and the documentation that you are publishing are actually correct. That if I read your tutorial, I actually learn how to use your framework instead of learning broken commands because 3 releases ago you changed something and you forgot to update your documentation. So whenever you start writing the documentation, you should start already in the form of writing it test.
All right.
Yeah, good. Yeah, for the code itself. Yeah. No. Yeah, I was probably not very good at explaining it, but what I was trying to say is that they serve two totally different purposes. So this is testing that the documentation is correct. It's not testing that the code is correct. While while the unit test tests that the code is correct. So you should absolutely do both and move them in parallel. There is not one that is first or second. Yeah, we can
okay,
talk
yeah,
outside.
so you could talk about it afterwards.
Yeah,
yeah, great. So, yeah, great. So,
I offer consulting in exchange for beer.
so for the questions unanswered, you could always ask on Discord or have a chat with him if he's there around. Oh, great. Yeah, so we'll do that. All right, yeah. Thank you so much, Alessandro.
Thank you.